Assalamu alaikum, my dear students of class 10. I think by the grace of Almighty Allah, all of you are well. Today I want to discuss about your general mathematics, chapter 8, geometry. I think geometry is important for all of my dear students because according to our previous board question, one CQ question always taken from this exercise. So this is important for your exam. Okay. This is our today class. I am MD Asghar Khan, Senior Lecturer, Department of Mathematics. At first, we can consider this following figure. First figure is wheel, and second figure is ball, and third figure is earth. All figure like as a round figure, and all are see to be the objects above are round to be round to see. Okay, then our exercise is chapter 8 is circle, and after class student will avail and what content we are going to discuss. First one is definition of circle, diameter, radius, chord, tangent and secant. Secondly, we want to discuss know about angle at circle and angle at center. What is angle at circle and what is angle at center. Then we want to prove the theorem 18, 20 and 24. Now definition of the circle. What is the definition of the circle? Circle is a geometrical figure. Is a geometrical figure in a plane whose points are equidistant from a fixed point, and this fixed point is the center of the circle. If we can consider a circle like this, this is the center, and all point on this circle, are the equidistance from the center, and this is called a circle. And this geometry is said to be is called a Euclidean geometry, because the Greek mathematician Euclid first introduced this type of geometry, and that's why it is called a Euclidean geometry. Okay, Euclid is a Greek mathematician, and that's why this is called Euclidean geometry. Okay. Now, next topic is this is a circle, and this is chord, and this is the radius, and this is the diameter of a circle, and this is the tangent of a circle. These topics you have to must memorize, because this is the important for our basic. And what is tangent? You have to know this. What is chord? What is diameter? What is radius? Okay. Now we want to see the definition of this term, of those terms. First one is chord. What is chord? The line segment connecting the two different points of the circle is a chord of a circle. If the joining of the 2 points, if this point is A and this point is B, then AB is the chord of a circle. Now, what is the definition of the diameter? And you have to know diameter is also a chord. If any chord passing through the center, if any chord is passing through the center, this is called a diameter of the circle. Now, what is radius? Radius is the half of diameter, okay. Now, dear student, what is this? This line, which is the line of this line is touches the circle, and this line is intersect the 2 points of the circle. What is the difference between them? First one is tangent and second one is secant. Okay. So first one is tangent. The straight line has touched the circle at a point. What is secant? The straight line has cut the circle at a 2 point. If the straight line intersects the 2 point of circle, this is called the secant, and touches the 1 point, this is called a tangent. I think all students can understand these things. Okay. Now, another important topics, what is angle in a circle and what is angle center angle, and what is exterior angle. I think that this is the important for your geometry. If we prove this theorem, then these topics will be important for you. At first, what is angle in a circle? If any angle created on the circumference, the boundary line of the circle, this is called a circumference, this is called angle in a circle. And what is center angle? The angle which is created with center, this is called the angle at center. If we can denote is A, if we can denote is B, if we can denote it C, then ABC is its angle at circle. If we can denote is B, if we can denote is C, then BOC is a center angle, exterior angle. If this is the triangle, and this is an interior angle, this is called the exterior angle. You have to know, please student, note it, the exterior angle is the sum of other two interior angles. If this angle is A and this angle is B, and this is an exterior angle, if you can denote it by C, then C is equal to A plus B, because exterior angle is the sum of other two interior angles. Okay. Now, this is the theorem number 18. I think that it is the very important theorem. At first, you have to consider carefully the statement of theorem. What is the demand of the statement of theorem? It is very important. At first, you have to understand it. All equal chord, what is given and what statement we have to prove. You have to think it carefully. Here, two equal chords of a circle are equidistant from the center. That means two equal chords will be given, then their distance from the center will be equal. You have to prove it. Okay, that means AB and CD are two equal chords. If we can draw this circle in this way, I think that it is easy for you. This is the center, and this is a chord AB, and this is the chord CD, and two chords are equal. And what happened? If the two chords are equal, then their distance from the center will be equal. If this is the distance E, if the distance is C, then what construction should be need? Join OA and OC. Okay. Join OA and OC need to be joined for complete this proof. Okay. And they are perpendicular distance. OE and OF, sorry, this is OF, and OE and OF are perpendicular distance. This is the perpendicular distance. Okay. So, in first step, if we can draw this figure in this way, I think that it is easy for you. Okay. If here O is the perpendicular on AB, because O is the perpendicular distance, then and OF is the perpendicular. This is the F. This is the F point, OF. So this is the perpendicular of perpendicular distance of CD from the center O. Then if that perpendicular on of chord AB according to the theorem 17, then this chord bisect by this perpendicular line. That means OE is perpendicular AB and OF is perpendicular CD. Then AB and CD bisect by those perpendicular line according to the theorem 17. So AB is bisect by OE because OE is the perpendicular, so A is equal to B, OE is equal to B, and CF is equal to DF. CF is equal to DF. So we can write A is equal to half of AB and CF is equal to half of CD because E is the middle point. Okay. And here this is the given. If the two chords are equal, this is the given condition, two equal chords. Okay. So if we can multiply in both sides by half, if we can multiply this line by half and this line by half, then what happened? And half of AB we can write it A, and half of CD we can write it CF. So this is the proof for step 2. What condition we have proved? A is equal to CF. Okay. A is equal to CF. Now we have to consider the two triangles AOE and OCF. Okay, OAE and OCF. Then we want to congruent those triangles. Okay, student, you can say which side are equal of those two triangles. OA is equal to OC. OA is equal to OC because they are right angle hypotenuse and radius of same circle. That's why two are equals. And A is equal to CF. A is equal to CF because already we have proved by the step 2. So A is equal to CF. That means those two triangles are congruent. If the two triangles are congruent, then their all sides and all angles must be equal. That's why we can write OE and OF are equal because they are two sides of this triangle. Because already we have proved they are congruent, then they are two sides equal. And OE is the perpendicular distance of AB and OF is the perpendicular distance of CD. So their distance are equal. If two chords are equal, so their distance are equal. This is our complete proof of theorem 18. Now we want to prove the theorem 20. This is the statement. The angle subtended by the same arc at the center is called the, what is arc? If we consider this circle, this is the circumference, boundary of the circle is called the circumference of the circle. The segment or portion is called the segment, arc length of a circle. So AB is the arc length of a circle. AB is the arc length of a circle. So the angle subtended by the same arc at the center is the double of the angle subtended by its any point on the remaining part of the circle. That means this is angle at circle by angle remaining part of the circle BAC, and this is angle at circle. So BOC is the angle at center and BAC is the angle at circle. So what condition we have to prove? This angle. What condition we have to prove? We have to prove angle BOC. Angle BOC is the double of angle BAC. BAC. Okay. We want to prove BOC is the double of BAC. Okay. This is our condition to be proved. Okay. So what is the construction? Just join the line AD, which is passing through the point center of the circle. So you can see the two triangles. First one is AOB and second one is AOC. At first we want to consider the triangle AOB. So it is easy if we can isolate this figure, isolate this triangle from this figure, then I think that it is easy for understand. Okay, now we have isolated this figure from original figure. Okay, just we want to consider this triangle AOB. Okay, AOB, consider the triangle AOB. So then triangle BOD is an exterior angle. At first already I have discussed in exterior angle of triangle is the sum of other two interior angle. This is the properties of a triangle. Okay, already this is the side note, sum of other two interior angle. Another one, if we consider AOB, AO is equal to OB. Why the two sides are equal? You have to go to the previous page. Why the two sides are equal? O and OB are equal because they are radius of same circle. Okay, the radius of same circle. Radius of same circle. So if two sides are equal, so AOB is an isosceles triangle. For the isosceles triangle, their two base adjacent angle are equal. So this angle and this angle are equal. And the name of this angle is BOA and name of this angle is ABO. So BAO and ABO are equal. Okay, in step 1, in this angle, we can now replace by this angle BAO because both are equal. If we can replace this angle by this BAO, so BAO plus BAO is equal to 2BAO. This is BAO, BAO, this is BAO, BAO, so BAO, BAO, 2BAO. So BOB is equal to 2BAO. That means this angle is the twice of this angle. Okay. That means already we have proved this angle is the double of this angle. Okay. If we consider angle AOC, then according to this, similar to this triangle, what condition we can prove? It is easy to say COD is equal to CAO, twice of CO, have similar condition. Okay. COD is equal to 2CO. Okay. If we denote this is equation 1. If we denote this equation 2, then what condition? adding two equation, then BOD plus COD, 2 BAO, 2 CAO. Okay, taking 2 as a common, then BOA plus COA. BAO plus CAO. The sum of two together, two angle is equal to BAC. Okay, together two angle is BAC. So BOC is equal to twice of BAC. This is our theorem 20. Now we want to go theorem 24. My dear student, in theorem 23, we want to discuss what is theorem 23. What is theorem 23? Theorem 23 is if this is the circle and this is the quadrilateral, if this quadrilateral is inscribed in any circle, if this name of quadrilateral is ABCD, then this is the center O, then theorem 24 is if ABCD are concyclic, then the sum of two angles are two right angles. Sum of two angles are two right angles, opposite angles. So if ABCD are concyclic, then their opposite angle are two right angles. This is important for this theorem. If we prove this theorem, okay. Now we want to prove this theorem. Okay. If what condition is given, if two opposite angles of a quadrilateral are supplementary, then the four vertices of quadrilateral are concyclic. In previous theorem they are concyclic, then they are supplementary. Now this is the converse. If they are supplementary, then we have to prove they are concyclic. Okay. I think that our given condition is their opposite angle are two right angle. That means ABC and ADC are two right angle. Okay, this is given. We have to prove ABCD are concyclic. Okay, what is drawing for proof? Since ABCD are not a concyclic because they are not lie in a straight line. That's why they are not collinear. What is collinear? If the line not lie in a straight line, there is collinear. So ABC is not a collinear. Okay. So if you prove any theorem, we want to say again, you must be know what is given condition and what is we have to prove. It is important for all theorem. I think that you have to memorize, you have to know, and at first you know which thing is given and which condition we have to prove. Okay. Now, this is not a collinear, so we can draw a circle passing through the 3 points, and other side of AD, the circle intersect at a point E. Okay, so now we can say ABC is a inscribed quadrilateral ABC. Okay, according to the theorem 23, if this is inscribed in a circle, then their opposite angle are two right angle. So AEC and ABC is equal to two right angle. This is the in a square quadrilateral. But our given condition is this. This is our given condition. So this is equation 1 and this is equation 2. And their right side are equal. So left hand side also be equal. Left hand side also be equal. If angle ABC and angle ABC from left hand side and right hand side, it will be discarded, then angle AEC is equal to angle ADC. After this step, we have proved this angle and this angle are equal. But if we consider angle CED, if we can isolate this figure, just you can consider this way. This is easy. I think that if we can isolate this figure, this is A, this is E, and this is D, and this is C. Already we have proved AEC is equal to ADC. But my dear student, according to our exterior angle of a triangle, it is not possible. देखो, an exterior triangle in triangle CED. So angle AEC is an exterior, so sum over the two angle. Sum over the two angle. This is our properties of a triangle. So AEC not greater than is greater than angle ADC. So AEC is the sum of two angles. So it must greater than individual of two angles. So of course the greater than ADC. But here equal and here is greater. So both are contradiction. So what should be decision for two equation? If E and D are two different points, so this different thing will be arise. So for remove these two unparalleled logic, for remove this, then D and E are not be a different point, cannot be different point. So D and E, D meet with E, therefore if E is encircled, then D also encircled. So therefore ABCD is a consecutive. I think that you have understood this theorem and you have to factorize this theorem, those theorems in your home again and again. Then I think that it will be easy for your exam. Okay, your homework is not write down your homework. Your homework is 19, 23, 25 to 27. This is your homework. I think that you have to do this theorem in your home. Okay. I think that this is our today's class, and Allah Hafiz for today's.